All right.
But then don't expect me to.
Hi. Say hi, Branko.
Why am I still doing this?
Why are we still doing the differential equations? Oh my God, we've been doing it for weeks. So I have up here a system.
Hold on, it's blurry.
Oh man, come on.
There it is.
Nice. How'd you do that?
It's magic.
Nice.
Serbian
Okay.
magic.
So there's our system. Let's use our formula sheet, which I've already done for you. And what are we supposed to get, Branko, from the formula sheet for this matrix? We get lambda 1. What is lambda 1? Lambda 2. I'll write the numbers. Lambda 1 is 1. Lambda 2 is 4. And those are?
Eigenvalues.
Good. And each eigenvalue gets a eigenvector. And these are right off the formula sheet. Didn't do any work. No math. I'm just following the formulas on the sheet. Now this guy comes out to be 3, 3 from that matrix. It's a 3 divided by 4 minus 1. But we can also use 1, 1, because any constant multiple of an eigenvector is also an eigenvector. The pros use the simplest eigenvectors they can. So there we go with the eigenvalues and eigenvectors. Nice. Yeah. All right, now, solution. Y equals, okay, so C1 e to the t, that's for lambda value 1 in front of the t, vector 1, 0, plus C2 e to the, Branko's turn,
4t.
4t, vector 1, 1 is good. Now let's just rewrite this real quick. I just want to see it as a vector. So it's C1 e to the t plus C2 e to the 4t, comma, 0 plus C2 e to the 4t. And now we can apply the initial conditions. So when t is 0, we get the following. I get the vector 2, 1, and it's equal to, when t is 0, what do I get?
When t is 0, you get C1 plus C2. Yeah, that's the little multiple times.
Yep.
C1 plus C2.
So we can see right now, C2 has to be 1, and if C2 has to be 1, then C1 has to be 1. You just see it by looking. No heavy-duty work. So let's write down what we know. Here's what we have. We have, for this differential equation, with initial condition, the specific solution is vector. Both C and C1, C2 are 1s. E to the t plus e to the 4t, e to the 4t, and that's it. That's the solution to my system. Okay? Now what we're going to do is something that's not in the book, and you might regard it as a total waste of time, Branko, because that's Branko's role today, is to complain. He's supposed to complain about what a waste of time all of this is. This is just terrible. Oh my God. Why are we still doing this? Can't we do something new? And I just want to have an excuse to do some linear algebra with you guys. So if you notice, what we have here is we have, let me see if I write down here, it'll look good. I have y prime equals ay. And there's a thing in linear algebra called the inverse matrix. And so a, you write it as a to the negative 1, and that's the inverse of the matrix A. That's what a to the negative 1 is. I'd like to show you how to find. Do you know how to find the inverse of a matrix?
I do.
All right, let's do it. I do it like this.
Yeah.
I write the matrix, and then I write an identity.
Yep.
And now, here's the rules, kids. You can multiply across a row. You can add a row to another row.
And add multiples of the row.
And then you can do both of these together. So it's kind of nice. So those are our 3 rules. Let me get out of the way so you can see our 3 rules. And the goal is here's what we're trying to get. We're trying to get 1, 0, 0, 1, dot, dot, dot.
Some other.
And then this guy here will be A inverse at the end.
Yep.
So that's what we're trying to do. So Branko, what would you do first?
I would go row 1 minus 4/3 row 2.
Good God. That's
Can we do that?
we can do that.
But
Row 1 minus 4/3 row 2.
Would that be 4/3 or 3/4?
I think we want 3/4
3/4 then.
because we want to get a 1 out of the deal.
Right. So
Let's do 3/4 row 2.
So
it's
you
like
rewrite the
multiplying
first
by
row,
3/4 here,
or you rewrite
negative
this-
3/4, and then adding straight up. So the 1 stays a 1. We killed off the 3. And then this 1 stays a 1 because it's 0 plus 1. And then negative 3/4 plus 0.
So it's negative 3/4.
So one of the ways to think about this, ladies and gentlemen, is this little thing that started with an identity matrix is going to keep track of what we do to make this an identity matrix. In other words, undo the original matrix. So right now we've got almost an identity matrix. I'll copy this other row for now. But now it's just divide by 4. So now the last thing we're going to do is 1/4 row 2. And that's going to give us the 1, 0, 1, negative 3/4, 0, 1, 0, and 1/4. And this guy right there should be A inverse. Let's check. So A inverse times A should always be the identity matrix. And the order doesn't matter. So let's multiply. 1 times 1 plus 0. 1 times 3 minus 3/4 times 4. That's 3 minus 3. That's a 0.
Yep.
0 times 1, 1/4 times 0. 0 times 3, 1/4 times 4. Check. Our inverse is correct. And now let's use it. Because if this is correct, let's not lose that inverse matrix. It's right there, so I can erase it here. If my differential equation is correct, then it must also be the case that A inverse times Y prime is equal to Y by multiplying both sides by A inverse. If I multiply both sides of this equation by A inverse A gives me the identity, so that side's back to regular Y. And remember, we were always looking for Y. Well, we found it. So now we're just checking. So let's see. We never found Y prime, which we would be doing if we were going to do a check anyway.
Yes.
So let's find Y prime. Your go, Branko.
The derivative of the first one, which is going to be e to the t plus 4e to the 4t.
Correct.
And then the bottom one is just 4e to the 4t.
4e to the 4t is right. And now, this says here, if I do the matrix, 1, negative 3/4, 0, 1/4, times this thing that you just said, e to the t plus 4e to the 4t, 4e to the 4t, I should get back my original y, which we have written up here. Here's my original y. Let's see if it works.
That t looks horrible.
I know, let's make it look better. Okay, can everybody see okay? I think they can. You can zoom in at home if you want to. All right, so remember, it's row times column. This is one column. That plus sign still means this is one entry. So it's 1 times this. That's e to the t plus 4e to the 4t minus 3/4 times the 4e to the 4t. So the minus 3/4 times the 4's cancel, and I have 4e to the 4t
Minus 3/4. Minus 3e
to the 4t.
So
So
you're going to get,
I'm going to get e to the t plus e to the 4t.
which is our first
That's the first entry.
of y.
We matched. Now let's check the second one. That's even easier. 0 times the whole top is 0, plus 1/4 times the 4. That's a buns naked e to the 4t. No number in front. Check. So I don't know if you'd ever use this, but we're going to do one more because it's complicated and we get an excuse. But let me see how we're doing here for time.
9 minutes.
Yeah. Let's do it on a second video.
Okay.
Okay, so thank you.